Hi, in this video we are going to talk about graphing basic secant and cosecant functions. So let's start with secant, and what we're going to do, as we've done before with other graphs, is we're going to pick some values of x and then calculate secant of these values and essentially make a table of values. So let's go ahead and begin. At 0, secant, which is the reciprocal of cosine, is going to equal 1. At pi over 6 is going to be 2 square root of 3 over 3. Pi over 4 is going to be square root of 2. Here's going to be 2. At pi over 2 it's going to be undefined because the value of cosine is going to equal 0. And it's going to be negative 2, negative square root of 2, negative 2 square root of 3 over 3, negative 1. Continuing, negative 2 square root of 3 over 3, negative square root of 2, negative 2. At 3 pi over 2 it's going to be undefined again. And at 5 pi over 3 is going to be 2. And here's going to be square root of 2, 2 square root of 3 over 2, and then 1, and then 2 square root of 3 over, 2 square root of 3 over 3. Right? And let's go ahead and write decimal approximations so we can graph it. So obviously it's 1, this is about 1.15, this is about 1.41, this is 2, obviously undefined, negative 2, negative 1.41, negative 1.15, negative 1, negative 1.15, negative 1.41, negative 2, undefined, 2, 1.41, 1.15, 1, and then 1.15. So these are our values, and now we are going to plot them, and we're going to see what the graph is going to look like. Alright, so let's begin. At 0 we are at 1. At pi over 2, let me do that. So here is going to be undefined. That means we are going to have a vertical asymptote. Okay? But the values that you're going to get, so at pi over 4 it's square root of 2, which is about 1.41. And then here's going to be like this, and here's going to be 2. So this part goes like that. Now what happens on the other side? So here we're going to have negative 2. Here we're going to have negative 1.41. Right? And it's going to be negative 1.15, negative 1. So here the graph is going to start looking like this, and then once we go to the right of pi, it's going to go like this. So the graph is going to be looking like that. And it's somewhat of an interesting graph with a bunch of branches repeating like that, and then you are going to have a vertical asymptote again here at 3 pi over 2, and then again at 5 pi over 2. Okay, so what does the graph look like? That's what it looks like. I also have the graph of cosine graphed here, because when cosine is 0 you will have a vertical asymptote. Right, so here you have a vertical asymptote, here you have a vertical asymptote, but that's what the graph of secant looks like. So let's take a look at some of its main features that it displays. So the domain of secant is going to be all real values except where cosine equals 0. So it's going to be x cannot equal pi over 2 plus pi n where n is an integer. What is the range? I hope you noticed here, let me show you the graph again, that the graph simply does not exist between negative 1 and positive 1. It's either at negative 1 and above, or at, positive 1 and above, or negative 1 and below. So that means that the range is going to be from -infinity to -1, and then again from 1 to infinity. Has vertical asymptotes at every excluded value, like this. So vertical asymptotes are going to be at pi over 2 plus pi n. Where is this graph increasing? So this graph is going to be increasing on the interval from 0 to pi over 2. And then again, it's going to have a vertical asymptote at pi over 2. And it's also going to increase after that from pi over 2 to pi. And it's going to repeat every 2 pi. Where is it decreasing? It's decreasing on the interval from -pi to -pi over 2. And then also from -pi over 2, at -pi over 2 it has a vertical asymptote, and it's going to go to 0. And then it repeats every 2 pi. X-intercept, it does not have any. It's going to have one y-intercept at the point 0, 1. Has a relative max at several points, infinitely many of them actually, at pi, so it's going to be at x equals pi plus 2 pi n. And it's going to have relative min at points that can be described as 2 pi n. That, by the way, includes 0. Alright? And there is this graph has a period of 2 pi. Okay? So now we're going to go ahead and take a look at the graph of cosecant. So there's going to be some resemblance, you will see. Alright, so let's go ahead and start with the table of values. So let's go ahead. So it's 0 cosecant, which is the reciprocal of sine, since you're dividing by 0, is going to be undefined. Pi over 6 is going to be 2, then square root of 2, then 2 square root of 3 over 3, then 1, and then 2 square root of 3 over 3, then square root of 2, 2. At pi, where sine is 0, is going to be undefined again. At 7 pi over 6, -2, negative square root of 2, -2 square root of 3 over 3, -1, -2 square root of 3 over 3, negative square root of 2, -2. At 2 pi, again undefined, and then 2. So as far as decimal approximations, obviously 2, 1.41, 1.15, 1, 1.15, 1.41, 2, undefined, -2, -1.41, -1.15, -1, -1.15, -1.41, -2, undefined, and then 2. So you probably see that some of these values are repeating, just the different x values. Alright, so let's see what the graph is going to look like. So at 0 it's undefined. We're going to have a vertical asymptote here. We're also going to have another one at pi, and at 2 pi, as we already saw, because the graph is undefined. And so let's plot the points at pi over 4. I'm sorry, pi over 2 we have 1. So this graph, once you plot the points, is going to look like this. There's one branch here. It's going to have another branch here. It's going to have another branch going like this here. It's going to be another vertical asymptote. There will also be more on the other side, so there will be one more here, going like that. And there will be vertical asymptote at -pi. Okay. So that's what the graph of cosecant, the one in where the curve is solid, looks like. And I also have the graph of sine here as well, so that you can see wherever sine equals 0, you are going to have a vertical asymptote. So at 0, at pi, at 2 pi, at negative pi, at negative 2 pi. So yes, it does resemble the graph of secant, is just shifted by pi over 2. Just like the graphs of sine and cosine are essentially the same graph, is shifted by pi over 2. So let's discuss some of the features. So the domain is going to be all numbers except where sine is 0, so x cannot equal pi n, where n is an integer. The range, I hope you noticed, is pretty much the same thing. You do not have anything between -1 and 1, so it's either from 1 and up or from -1 and down. So the range is going to be from -infinity to -1, and also from 1 to infinity. It's going to have vertical asymptotes wherever the values of sine are 0, so it's going to be at x equals pi n. This graph is going to be increasing from pi over 2 to pi, and then again from pi to 3 pi over 2, and it's going to repeat every 2 pi. Every 2 pi. It's going to be decreasing for some of the intervals you can list from negative pi over 2 to 0, and again from 0 to pi over 2. Okay, and it also repeats every 2 pi. It has no x-intercept, and this graph also has no y-intercept. Has a relative max at the points that can be described as x equals 3 pi over 2 plus 2 pi n. And it's going to have relative min at the points that can be defined as pi over 2 plus 2 pi n. Again, n is going to be an integer value, and this function also has a period of 2 pi. Okay, I hope this was helpful.